and a warm welcome to the AI with Arun Show. In this episode, we are going to talk to Harsh Nigam, who is the leading expert in the world of AI. He'll talk about what AI agents are, what are evals, how do we run them. There's a lot of anxiety in the world of AI about how to run and test AI agents. And that's exactly the anxiety that we're going to deal with and tell you how to address that. And Harsh Nigam is an AI expert. So, Harsh, a very warm welcome to the show.
Thank you, Arun. Thanks for having me.
Excellent. So, Harsh, before we go talk more about it, so talk to our viewers about some very foundational elements. There's a lot of confusion about what AI agents are, what are evals, and how do we actually build these and run them in a reliable manner? Because if you're learning in a production environment, you can't have hallucinations. So, talk to our viewers about some of the foundational elements.
Okay, sure. Let me start by explaining like what's the fundamental difference between an AI agent and an basically a LLM chatbot. So when you are talking to your ChatGPT, it is mostly giving you answers. Like it, you can consider it as a better version of Google. Like you don't have to browse through the links to get the right information, compile them in your head, and then formulate the answer. So these AI that as we know it right now just does it for you. But when you talk about agents, they are specifically meant to execute tasks for you, like real tasks that you would. So instead of just providing you back with information, agent can execute the task for you end to end, like creating a presentation or creating a Word document or modifying an Excel sheet or basically developing a software for you. That is the most popular use case we have today. So as opposed to basic LLMs or AI, as we knew last year, these are more complex systems. They have more components. Like if you were just talking to an LLM, it would be just an interface, which would be calling the model directly, and you will get the answer back. But agents don't work like that. Agents have many components, such as agents have access to tools. Agent might have a database that they can access to, like like if your agent is for a payment reconciliation, it could be talking to your Stripe database. It could be talking to your own database. It could be fetching some conversations from your Slack, or it could be also creating tickets on Zendesk. It could be performing a lot of actions. So one, the integration layer, then you have the tool layer, like how these tools are, like how these integrations are connected to the agent. That is one thing. Then you can have your internal databases. Then you have like modern agent systems also have things like a memory system wherein the agent will remember what you told it the last time or what it did the last time. So it can maybe pick up from there or keep context about yourself. And since these agents are more complex systems as compared to before, they need a lot of insurity. Like we need to provide a lot of insurance assurance to ensure that they work right in production. And so we have various different methods to ensure that. So one is obviously like when you build an agent, you can test it manually. Like you can go ahead and chat with it day and night and see where it fails, where it doesn't. But that is obviously the easiest and the first approach, but that is not the scalable one. When you're building like products, agentic products for let's say a million people, you can't probably estimate the number of queries you will get or the types of queries you will get or what might break the system, what might not break the system. So you need to build something scalable over that. And there's also an issue, like two underlying issues that plague the agent economy right now. Like first is the hallucinations, and the other is guardrails. I'll talk about the guardrails first, and then come to the hallucinations. So guardrails are needed. Why? Because let's say if you are building an agent in the finance industry, and the agent has a set of rules that it needs to follow, and a certain things that it can't do. Let's say you have a rule called don't issue a refund if the order value is below $20. Now, to ensure that the agent follow these rules, we need to set up some guardrails in place. Like this is a very basic example, but it could be around like pornography, it could be around toxicity, it could be around like Anthropic is very high on providing the users the best experience by calling it safe. And like if you want to ask the agent to develop you a nuclear bomb, it will just refuse. But that is the bigger picture. Like for an organization, for an individual developing agent, it could be as small as not issuing a refund. It is the same. Like the models have guardrails of their own, but your system also needs some guardrails of your own while you're designing it. So that is the first thing. And the other thing is hallucinations and the accuracy of the agent. So The agent can tell you, okay, I did this for you, but how do we know did it actually do it? Or is it just hallucinating? Or is it presenting the right information? So there are two ways to prevent that. First is again setting up guardrails. So it like designing the systems in such a way that the agents can't hallucinate. This is the tougher task. The other thing which we can do is like testing them thoroughly at scale and seeing where they fail, how they fail, and then improving the system in iterations. So you reach a point where the hallucination is like minimal to what you expect. You can't eliminate hallucination at this point in time in history, but you can reduce it to like less than 1%.
So that's great explanation of AI agents, what they do, uh, particularly about hallucinations and guardrails. Harsh, so how do we test these kinds of agents that we build?
So there's a concept in like it has like AI has been around for like 20 years, 20 to 25 years, and like the AI as we know it today is mostly around LLMs, but the concepts have been around for 25 years now. So there's a thing called evals, like evaluations that we use to evaluate AI models, be it normal machine learning models, be it the modern LLM, generative AI. The concept remains the same. The idea is to create a suite of test cases which will basically contain most of the use cases or most of the scenarios that your agent or your AI can encounter, and evaluating your agent or your AI against those set of test cases. So that has been the norm for years now. But the problem today is the agents are capable of doing a lot. So you need to do that testing at scale. The traditional methods like creating them manually, like sitting down one day, one weekend to create a whole bunch of evals doesn't work anymore because your agents are being touched by a million people. Probably like OpenAI is being touched by a billion people right now. They can't possibly test it manually. And the other thing that we are seeing over here is there's a lot of anxiety amongst the leadership, especially folks in fintech, healthcare, and all of those areas where the impact can be brutal. And like if we provide the wrong information, if we issue the wrong refund, or the agent provides a prescription that it is not supposed to do, or it makes the person suicidal, they could have catastrophic outcomes, and we don't want that. So enterprises are building agents right now, but mostly they are keeping it inside, trying to be sure if they work or not, trying to be like, it is basic human nature to be like conflict avoidance or like catastrophe avoidance. So, but this is also impacting the agent economy right now. Like agents are being built, but they're not being released in the open for just the fear and anxiety. We call it the pre-launch anxiety specifically. Like we coined this term. So
So thank you, Harsh. This is very helpful. So Harsh, if I'm a let's say a director responsible for testing and QE in my organization, and it could be any organization, what are some of the things that I should have in mind while my engineering team is designing these AI agents to do specific tasks? For example, it could be in the area of customer experience or in the area of financial reconciliation or something, or maybe in HR. What are some of the key things that I should have in mind for my testers and developers so that they can work and we could have an AI agent that works reliably? Because you alluded to earlier that building reliable agents is one of the key things. So
mhm.
talk to our viewers about some of the key things that I as a director or the leader responsible in my organization should think about.
Sure. That's a good question. So instead of telling you some key points about that, I can walk you through the process that we follow to ensure like we build the best agents out there. And it starts by basically outlining how would any project manager approach this is to like talking about the PRD, but how we do it, like PRD, we create the PRD, but it should focus on certain key components before even getting into the functional details. So we start by what the agent should not do instead of first talking about what the agent should do. So we start by building the guardrails. We have a basic idea of agent in mind, like, okay, we are like, let's say we are building an ITSM agent and it is supposed to solve tickets for employees. So that is okay. But we need to first identify what it isn't supposed to do. That agent shouldn't be providing waffle recipes, right? And it shouldn't be like if the budget to issue a laptop is $2,000, it shouldn't be issuing a MacBook Pro maxed out at M5 and one TV RAM at $5,000. So it shouldn't do that. So we start by outlining what it shouldn't do. We write everything down, then refer our documentation that we have at company level, and like human capabilities are limited when we look at agents right now, like that's the deal right now. So then we take our documentation, the things we put out manually, and then we use existing AI agents, such as like we might use Claude or we might use ChatGPT to expand it. Basically, like it's not because we can miss out on details, but the agents are really good on details. We expand those guardrails into a massive rubric, and we then review it manually. We start with that. Then the next step after creating guardrails is creating the test cases. So we start by mapping out the happy paths first, like what are the ideal scenarios, like what is the ideal scenario which the agent can operate in. Let's say for the ITSM agent, like it can issue additional charges, or it can provide you with tech support, like your laptop isn't functioning or you have an internet issue or something like that. Those are all the happy parts. We ask the customer to basically go ahead in their existing data, what the cases have been, and then just filter out the happy parts. We case Based on those conversations, we create test cases around that. Then we move on to edge cases, adversarial scenario, some of the toxic things, and everything. And we put everything in a test evaluation suite even before starting to build the agent. So even the first iteration of the agent that you build, let's say based on the test cases that we created, is at a 25% accuracy overall. Like we don't evaluate just on accuracy, we evaluate on hallucination, groundedness, knowledge base accuracy, and we have probably 20-25 metrics that we evaluate them on. So even if the cumulative score is 25%, that's a great start for first version. And now once we know what we have to build, how we test it, it's easy to get there. Like you can go from 25% to 95% in just a couple of weeks. Now that you have talked out what the agent should do and what the agent shouldn't do. So most of the firms they are mostly in the prototyping stage when they start out with that, and they extend it. What we recommend them to do is start with the prototype, check it out, but then take a pause, create those guardrails, create those evals, and then think about production. So your prototype shouldn't be the one going into production.
So, Harsh, that's a great way of. I like how you framed it by saying that you define first what the AI agent should not do versus what it should do. When you first said that, I was intrigued, but as you explained why, and it started making sense. And I just want to take a pause and tell all the viewers who are watching this, particularly those who are involved in testing or designing such test cases for AI agents. So this is a great way for you to get started, as Harsh recommended, because then life becomes much easier if you lay the guardrails first. Because the last thing you want is hallucinations or incorrect information, particularly for critical organizations or critical industries where if things go wrong, then it can be disastrous for the organization. Harsh, in your opinion, as companies are doing prototype first and then starting to think about moving on to production, the results would likely never be 100%. But in your opinion, what is a good percentage to get right before companies start thinking that, yes, this is now good enough for me to set that in production?
I would say it depends. Like if you are in the finance industry or the healthcare industry or insurance, you need to be at least 95% above that. And if you like coding agents right now, even if they perform at 70-75% of accuracy, they are good to go. Like humans are reviewing the code at all times. So it also depends on your end, like the end customer. Like if your end customer is technical enough, like if your end customer is developers or very technical people, or let's say if your agent is being used by a marketing head, they know their stuff, so they can spot things and correct them. But if you are building a consumer agent, let's say for shopping, or like we don't know their technical expertise, so it is a better idea to at least aim for 90-95% accuracy as opposed to like 70-75%. Technical users, you won't believe, that are more forgiving than the non-technical ones. They understand the nuances.
Okay, that's a very interesting insight. But I think more importantly, Harsh, what you alluded to is that it's important to know the users who are going to use these kinds of AI agents. So really understand the purpose of those AI agents, the goal that these AI agents are trying to solve, and then describe the use cases and figure out when is the right time to go into production. Harsh, but these systems are constantly learning, right? AI agents are constantly learning. So even if something is in production today, I launch it in production. Are there any tests that run even after an agent is in production? Or once the production is done, then you are done and dusted and say that, yes, I'm done? When does testing
So
really stop?
it never stops. So that is the bottom line. I'll tell you by an example how we do it. So once the agent is launched into production, depends on your compliance level, like how much data can you take back or save into your database. It is a great idea to capture all of those traces if your compliance allows, and maybe you can PII the data and anonymize it, evaluate those test case, like evaluate those traces, like if they were good or not, and spot the bad ones, convert them into test cases, like the ones we created in the first step. Convert, like if your agent hallucinated in a category called, like, let's say, order cancellation. So capture all of those bad cases, convert them into test cases, improve upon that, and ensure the next version doesn't do that again, and the subsequent versions as well, because agents are very probabilistic in nature. You might fix a case for order status lookup, but it might hallucinate again in order cancellation. So you don't even know which part you will fix and which part it will break. So it is a continuous process. It doesn't sound good, but this is what we have to do.
That's an interesting insight because in the olden world, people would say that yes, I'm done with testing and then move on to other projects. But in this case, we're talking about agents who are constantly learning and also drifting. So there is a case that has to be there for continuous testing. Harsh, you mentioned about PII, and let's talk about the PII and similar data which could land organizations in trouble. How should AI agents be dealing with PII? And particularly when you are testing, how should you be thinking about PII? Are there any specific testing that needs to be thought about for AI agents?
Of course. So when I was talking about those guardrails, it totally depends on the industry you are in. Like I mentioned, like if your industry requires that compliance, you should have a complete suite of test cases around that compliance. All of the points that you need to follow, and like you can call it a version of guardrails, but you can call it compliance guardrails or compliance test cases. So it is a great idea. Like, you will thank me later to have it in the first place rather than launching that and treating compliance as a post production thing. So right now you build the product, then you onboard a company to do the SOC 2 compliance for you, and then you figure out, okay, these are the mistakes that I need to cover. You won't get the certificate. So what you already know what you need to do, so why delay it for production and encounter an embarrassment with like an airline issuing overbooking tickets for a flight? So that happened last year. So why would you face those? Like I mentioned a guardrail example, but like this could be also be a compliance failure. But if that you have to comply, why not do it from day one instead of trying to cover up your tracks after that? Because once you go ahead and try covering up tracks for compliance, you might break other things in the process. And you might not, like you will break other things due to the nature of these underlying models. You fix one thing, other things break. So it's good idea to keep everything in place from the starting and focusing on that.
No, that's a wonderful thing, Harsh. You are right. It should not be taken as an afterthought, but it should be built as part of the overall process that you have right when you are thinking about what the agent should not do as you started the framing of this discussion. Harsh, is there anything else other than what we have spoken about that me as a developer, me as a QA engineer, or me as a leader of the organization should be thinking about as I'm designing, building AI agents and deploying AI agents and testing AI agents?
There's one very key insight that people tend to ignore, or I understand that agent space is very new, like less than an year old, that people have started building agents. But my advice to everyone who is building agents is don't be too dependent on the models. Treat it as like a normal engineering task which you were doing for years. Don't consider a model as a genie or like it's a magical creature that we have built out of sand, and don't just consider them those. Do a lot of engineering. Don't rely on models to respect your guardrails. Have code in place to respect those guardrails. Like, don't just rely on the models. And so, like, let's say for a simple task, like there is a tool you need to call to Stripe to issue refunds, and your company has a rule not to issue refunds for orders below $20. Why be dependent on the model to check that law, check that rule? Like, okay, this is a issue below $20, whereas it could be just a simple line of code in your tool that prohibits, like, it's a simple if and else case. Like, if the refund value is less than $20, block it. Do a lot of engineering. Meet a lot of developers, leaders who are trying to solve very simple rudimentary problems using the models underneath those agents, but those can be solved very simply through code. So don't, like, there is a new term called AI engineering, but don't forget that there is still a lot of engineering that you can do while building AI agents. So, and most of your problems can be solved using doing great engineering. Like, don't stop being a great engineer. So that is one thing. And aligning to that, you might have heard like there's a new term called harnesses. So they are solely built for this purpose. Like, it's purely engineering. Like, the agent harnesses are all about the engineering. So invest time in that. Don't just pick up an existing API like OpenAI API or Agent Force platform. Don't let them interact to your users directly. Have your code as a layer in between. Call it the harness. Don't be just dependent on the model.
And that's a very interesting perspective. I loved how you said, don't stop being an engineer. We don't have to use AI just for the heck of it if it can be resolved by simple engineering talents, engineering skills. Harsh, on that note, let me ask you this. 5 years from now, I know things are changing rapidly, but I'm still going to push you for that. 5 years from now, what does the role of a QA engineer look like?
5 years from now, it would be a very different role. And it's hard to predict the future, of course. But what I would just say is a QA might not be just a QA. It might, like, it could happen either ways. The engineers could turn into QA, engineers could start doing QA jobs, and QA could also start doing engineering jobs. So that is the overlap that I see in the near future. So basically like more generalist approach rather than a very specific resource with all the AI tools that we have in hand. So my advice for any QA starting out now is to make yourself a better engineer, and any advice for an engineer would be make yourself a better QA. So, and use the tools that you have to make the best out of it. So engineering, like writing code, is the least valuable task that you can do right now with all the AI models, all the Claude codes you have in the world. So, but like keeping yourself updated, having the right mindset, knowing what to solve and how to solve it is the key deciding factor. And don't try to limit yourself to one discipline. That's, I would say. And in 5 years, I see a world where almost everyone will become a generalist, not just the QA profession.
Wonderful. With that, we leave it here, viewers. So, in 5 years' time from now, all of us will become generalists because we'll have a lot of AI tools, AI agents will be doing very specific things, and we become the orchestrator that harnesses all of these things to do resolve specific problem for us. So, Harsh, thank you so much for your time. This has been a pleasure having you on the channel.
Thank you. Thank you.